Hello everyone. In this video we're going to be solving a cubic equation. So we have x minus x squared minus 2x cubed equals 3, and we're going to be solving for x values. What else could we solve for, right? So let's see how we can solve this problem in different ways. First method, let's go ahead and put everything on the right hand side where x cubed is positive. So it's going to be 2x cubed plus x squared minus x plus 3 equals 0. Now, when you get a cubic equation, the very first thing you should try is looking at the sum of coefficients. Why? Because if the sum of the coefficients is 1, you should know this, x equals 1 is a solution. Easy, right? If you replace x with 1 and you get 0, that means the sum of the coefficients is 0, and vice versa. But in this case, that doesn't happen, because if you do that, or just look at the sum of the coefficients, 2 plus 1 minus 1 plus 3, unfortunately, this is not going to give you 0. So x equals 1 is not a solution, at least that's what we know. But what is a solution and how do you find it? The next thing you can try is -1, because those are possible solutions. Or you can be a little smarter and use the rational root theorem, which says if there are any rational solutions, then they'll be made up of the factors of 3 divided by the factors of 2. What does that mean? So you're going to write it like this: factors of 3 divided by factors of 2. Casually we write it that way, but this is what it means. If you look at all possible factors of 3, such as plus minus 1, plus minus 3, and then we'll look at all factors of 2, plus minus 1, plus minus 2. And then we kind of take a combination of these, one from the numerator, one from the denominator. For example, if I take 1 and 1, I get 1. 1 and -1, -1 and 1, I get -1. But we know that they're not solutions, so no need to try those again, right? The next thing we can look at is, what if I use positive 3 along with a positive 1? So I could get something like 3 over 1, or I could get 3 over -1, or -3 over 1. By the way, these two mean the same thing, -3. So those are other possible rational solutions. Possible, I say, because we have to make sure they are indeed solutions. So these are just candidates, okay? And you need to test them to make sure they're solutions, or to prove that they're not. What about the 3 and the 2? Yes, of course, you can also make 3 halves or -3 halves, so on and so forth. So there's a couple different alternatives. You could also make plus minus 1 half from this and from that. See, quite a few options that you need to go through, plug in each one of them, or use synthetic division, whichever one you like, and then see if it's going to work. But that's a really long process, and yes, sometimes it works, right? If you don't have any other choices. Another alternative is going to be using the cubic formula. And that's a little painful, I got to tell you, but let's go ahead and proceed with this. Even if we don't finish the whole thing, at least you're going to get an idea, hopefully, because I use this method a lot, and there are some problems that I solved using this method, like completely used it, and you can hopefully look at those. By the way, check out the playlist on polynomials and other ones, because polynomial equations are fun, and this is one of them. I also have another channel called aplusbi, and that focuses on complex numbers. If you're into complex numbers, or if you're not into complex numbers, doesn't matter who you are, just check it out. Great, so let's see how we can handle this with the cubic formula. First of all, we need to make it a monic equation, which means the coefficient of x cubed, which is the leading coefficient, needs to be 1. So let's divide both sides by 2. And then we get something like this. So it's in that form. Now the next thing we do is get rid of x squared. And to do that, we're going to use substitution, because substitution is awesome. So let's go ahead and do this. Let's replace x with y minus. Now I'm going to go ahead and look at the coefficient of x squared and divide it by the degree of this polynomial equation, which is 3, right? What is 1/2 divided by 3? 1/6, right? So if you replace x with y minus 1 over 6, guess what's going to happen? You're going to get an equation that has y cubed, but has no y squared. It's going to jump to y, and then it's going to be a constant. So basically, this is going to be a depressed, that's what it's called. Not that it's in depression, but it's called a depressed cubic. So once you take care of that, you're not going to have y squared, so equation will be easier to solve. There's actually a formula, if you look it up, for equations like these, and I think Cardano was one of the guys who worked on this, and there's another guy called, I think, Ferrari, and then Tartaglia, a bunch of other people. Anyways, who has the original formula, right? That's another question. But if you can put an equation in this form, then solution will be easier, and let me go ahead and explain why. Not by using our equation, because I want you to try that, but I'm going to show you the general approach. So here's how it works. We basically look at an identity, which can be written as follows. So for example, when you see a cubed plus b cubed, how do you write it, right? Well, you can write it in so many ways. You can factor it, or you can just think about it this way. Well, if I cube a plus b, I will get a cubed plus b cubed along with 3a squared b plus 3ab squared from the binomial theorem, right? But I don't have those here, so I can subtract them. And to subtract them, I can factor out 3ab, so it's going to look like this. When you distribute, you're going to realize this is actually subtracting 3a squared b plus 3ab squared, which is the two terms in the middle, right? Can you visualize? Why is this helpful? Because if first of all, we would like to switch this around. So I don't think I want to write it that way. I want to write it this way. And of course, I'm going to have to move this a little bit to the left because I need room on the right. Okay, cool. Now, take a look at this. How are these two equations similar? You might be asking, right? Well, if you call this x, you'll get closer. But of course, there's a constant on the left-hand side, which we should put on the right-hand side. So we need to write it as follows. X cubed plus px equals negative q. P and q are constants, and the formula basically is like dependent on p and q. So those are the only two variables that you use in the formula, okay? And then what do you do next? Well, by setting a plus b equal to x, we're basically saying that a plus b is a solution of this equation, and a plus b is a solution of this equation. But what else do we know? We also know that, and you know what? I want to, instead of p and q, I think I can't write a good q, so I'm going to use m and n. Okay, so it's going to be a minus n. Allow me to change these. Plus mx plus n equals 0. Yeah, that looks better. Now, this basically means that the coefficient of x is m, but that's also negative 3ab. So we get negative 3ab equals m. And the constant term is a cubed plus b cubed, which is supposed to be negative n. From here, you can basically divide both sides by negative 3 and get ab equals negative m over 3. Now you have two equations. And guess what? It looks like a cubic system, but it's actually quadratic. You'll see why in a little bit. The next thing you should do is cube both sides. So in a way, we're kind of proving deriving the cubic formula. All right? This is cool. That wasn't intentional. I didn't intend to do it, but it just came up. So now we have this system, this one and this one. What we can do is isolate b cubed and write it as negative n minus a cubed and replace this b cubed with that. A cubed stays the same, and you replace b cubed with negative n minus a cubed, and then set it equal to this number. And now, if you distribute and put everything on the right-hand side, you get a to the 6th power plus n a to the 3rd power minus m cubed divided by 27 equals 0. Again, this may look like an hexic equation or hectic equation, but it's actually quadratic. Why? Because we're going to use the awesome method of substitution one more time. Let's go ahead and call or set a cubed equal to c. And that gives us c squared plus nc minus m cubed over 27 equals 0. And guess what? This is quadratic. So with the quadratic formula, we can solve it. So from here, c is negative b plus minus the square root of b squared minus 4ac. That's going to give you this number. Oops, that's supposed to be m cubed, not n cubed, divided by 27. And some of you, those of you who are familiar with the cubic formula will recognize this, right? 27n squared, because we can also write it as follows. We can kind of make a common denominator and then write it like this. And hopefully some people will recognize the pattern here. That's why those numbers come up. See, I gave you a formula for the solution of x cubed plus mx plus n equals 0. But wait a minute. These are not the solutions, because what is c equal to? C is a cubed or b cubed. So we have to set c equal to a cubed, which means a is supposed to be the cube root of this. But there are two values, so they're going to switch. To keep a long story short, since x is equal to a plus b, and a is one of the cube roots, b is the other cube root, they're opposites, or they come with the plus minus signs, in other words. Not opposites, but the different roots of the quadratic. So the solution is going to look like this. The cube root of negative n plus the square root of 4m cubed. They usually write the m cubed first. I don't know why. Maybe alphabetical order. Divided by 2. This is one of the cube roots. And the other cube root is just going to be the same thing with a minus sign. And that'll basically give you, and I'm going to have to move this again because I kind of, oops. I'm going to try to, let's see if we can do this. We're going to move this to the left. Okay, that's good enough, I think. I didn't mean to move the 2, but anyways, I got to keep it there, I guess. Plus 27 n squared. This should be under the radical over 27. And because we made a common denominator, right? And all of that is divided by 2. Okay, great. So that's one of the solutions. The most challenging part is simplifying this, and guess what? Sometimes you may get cube roots of complex numbers, which you have to take care of, so on and so forth. So it's not always the best method, but there's another method that uses trigonometry, so on and so forth. But this is the first method. That's why it's super duper painful. Okay, here's the second method. The second method actually uses a really smart idea. That's why I put that thumbnail there, like think smart. I know some people are going to object to this and say, hey, this doesn't always apply. Of course, this is a competition level problem. Pretty much all the problems on my channel are that way. So you know that there's always an elegant trick to these problems. That's why there's more than one method to do it, and I like to present all of them. So here's what we do. We kind of manipulate this expression, but again, let's move everything to the right-hand side. So it's going to look like this. Great. But at this point, you got to think really smart. And here's what we're going to do. I see the x cubed, and I see the 3, and I see these two terms. That kind of tells me if I'm familiar with formulas like this. X cubed plus y cubed, and x cubed minus y cubed. But particularly, one thing will stand out. I'll show you how. But these are the formulas, and actually to just write one compact formula, we can change this to a minus sign. This will be a minus sign, and this will be a plus sign. This is always a plus sign, by the way. Make sense? Plus, minus, minus, plus. Now, here, we can apply that formula. I'm going to erase it because you can find this anywhere. Now, but how do we use it? Well, this is x squared minus x. If only I was able to add 1 to it, this would be part of x cubed plus 1. Why? Because x cubed plus 1 is made up of x plus 1 multiplied by x squared minus x plus 1. Does that work though? Yes, it does. Because if you take away 1, you're left with a 2, which you can give to 2x cubed. And this is what your equation looks like after the manipulation. What is the manipulation? No big deal. But splitting the 3 into 2 plus 1 and splitting this into 2 pieces. And each piece is factorable. How? First of all, you can take out a 2 here, and then just keep this as is, or just put a 1 in front of it so that we know how to factor it. Now this is a sum of 2 cubes. You know what I'm talking about? And you can factor this as x plus 1 times x squared minus x plus 1 plus 1 times x squared minus x plus 1. And the whole thing is equal to 0. Beautiful. Now, Houston, we have a common factor, and this is it. So let's factor out x squared minus x plus 1, and then we get 2x plus 2 plus 1 equals 0. So we were able to factor this into a linear factor, which is 2x plus 3, and a quadratic factor, which is not factorable, and its solutions are complex. That's why it's important to know or learn more about complex numbers. That's why I made a channel for you guys. One more time, shameless plug promotion, aplusbi. Check it out. Now, from here we get, basically this gives us x equals negative 3 halves, and then this gives us complex solutions. Let's find them using the quadratic formula. negative b plus minus the square root of b squared minus 4ac. That's going to give you square root of 3I divided by 2. And again, I think this came up in another problem. Was it yesterday? I think on this channel, not on aplusbi, but on SyberMath. Anyways, this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe. Take care. Don't forget to check out SyberMath and aplusbi. And bye-bye.